So I'm going to go over a couple of calculations that are pretty common for this kind of material related to frequency, wavelength, and the speed of light. So the radio station, local radio station called Kiss Country, broadcasts at 93.7 FM, right? And that actually means that it has a frequency of 93.7 megahertz. So what is the wavelength of its signal in meters? So the relationship is C is equal to lambda nu. This is the frequency, okay? And this is the wavelength, and it will be in meters if this is in hertz, right? And this is 3.00 times 10 to the 8th meters per second. And that's a constant. Well, we're going to treat it as a constant in this class. So in order to calculate the wavelength, we'll need to know the frequency in hertz and not megahertz. So we're going to say frequency is 93.7 megahertz. And then this is the same kind of calculation that you did before. I have mega is a prefix, and so it's 1 megahertz is 10 to the 6th hertz, like this. So we're going to end up with 9.37 times 10 to the 7 hertz after the megahertz cancels out. And again, we haven't looked at these specifically in a while, but mega equals 10 to the 6, so you want to keep those kinds of things handy still. And then we can plug it into the equation. Now I need to know lambda, so that's going to be 3. I'll do the rearrangement first. That's C over nu, so that's going to be 3.00 times 10 to the 8th meters per second divided by frequency, which is going to be 9.37 times 10 to the 7. And then the unit hertz literally means, again, 1 over seconds, so 1 divided by seconds. And so since I'm dividing through by this, I'll invert it, I'll flip it over, and I'll multiply it. And the seconds, the per seconds will cancel out like that, okay? So you do the calculation, and you should get 3.20 with sig figs. It's actually 3.2017, I think, but 3.20 meters. So that's not, that's like 3 yards, 10 feet, put it in sort of American terms. It's not that long, right? That's the wavelength. Now you don't see it, again, because it's an oscillation in the electromagnetic field that's outside of the visible range, right? Okay, so another common kind of conversion calculation that we see is the conversion of light years to kilometers or miles or something like that. And so this is one of those questions. It says one of the nearest stars that might have habitable planets is Alpha Centauri at a distance of 4.37 light years from the sun. A light year is the distance that light travels in 1 year, 365 days. How far away in kilometers is Alpha Centauri from the sun? So it's very similar to one of the questions in the book, one of the even questions. Okay, so we have to sort of break this down. This is what we're given, right? 4.37 light years. A light year is how far it travels in 1 year, 365 days. And we also know the speed of light. We know the speed of light is 3.00 times 10 to the 8th meters per second. Now, to get to the distance, right, I'll take the time. This is time. Because it's in terms of years, right? And so we're going to have to take the years, convert it into days, and eventually into seconds so we can use this. But then it asks for the answer in kilometers. Now, when you do this calculation then, we're going to have to think about years to days to hours, right? To minutes, and then seconds, and then we're going to go to meters, and that's where we're going to use this, and then we're going to go to kilometers, okay? So let's sort of lay this all out. I want the distance in kilometers. That's what I'm looking for. My given value is 4.37 years times 365 days in a year times 24 hours in a day. And I'm just thinking about where I'm going in my map, right? So I've used my days. Now I'm at hours. I need to go to minutes, right? So every hour is 60 minutes. And then every minute is 60 seconds. And I needed to get to seconds because the unit of the speed of light is meters per second. And this is where I convert between time and distance. So I don't know if I can get it all on here, but 3.00 times 10 to the 8th meters per second, like that. So my hours have canceled, my minutes have canceled, my seconds. And so now I just need to go 1 kilometer is 10 to the 3rd meters, or 1,000 meters. So that gets me all the way there. And so now I can sort of happily go and calculate. I run it all through my calculator, right? Basically everything's in the numerator except for the 10 to the 3rd. So I'm just going to multiply straight across from here. From here all the way over here, and then divide by 1,000. And that gives me 4.13 times 10 to the 13 kilometers. That is a long way. Again, when you have these light year problems, one of the things, and you get better at these kinds of things as time goes on. Anytime you have a time-based thing, you need to get used to the idea of, like, you're going to have to get to seconds, because that's usually the SI unit we're dealing with. Even like in frequency, it's per second, right? So we're going to have to even do things like that in terms of converting time over to seconds.